All right, so today's notes are on solving systems with elimination. Our content objective is to solve linear systems algebraically with elimination, and our language objective is to use the correct terminology when explaining the process of solving linear systems with elimination. So this again, just to remind you, we have three methods for solving a linear system of equations. We have graphing, substitution, and this is the last one we're going to learn in this class, elimination. So you can also use matrices. We're just not learning about them in this class, but we're learning about substitution, elimination, and graphing, substitution, elimination. So elimination is the last of those three. You may have also done this in Algebra 1, but we're going to refresh how to do this today. So our first step is going to be, if you remember how the way elimination works is you add equations down and it eliminates one of the variables. So in this problem, in this first example, since 4x and negative 4x are additive inverses. Additive inverses, just so you know, are numbers or terms that when you add them, they cancel out. So they sum to zero. Additive inverses are terms or numbers that sum to zero. So since they're additive inverses, we can start right away by adding the two equations. And we do this vertically. I'll show you what I mean by that. So we're adding them straight down to cancel out x. So the way this works, I have 4x plus 2y equals 9 and negative 4x plus 3y equals 16. Since these are additive inverses, or they sum to 0, I can cancel them out, and then I'm just going to add the other numbers straight down. So 2y plus 3y is 5y, 9 plus 16 is 25. So I've canceled out x. Now I'm just going to continue to solve for y. So I'm going to divide both sides by 5, and I get y equals 5. Now that I have my y value, I'm going to finish this off with substitution. So I have to substitute into y for one of my original equations. So I'm going to substitute y to solve for x. Use one of the original equations. It does not matter which one, so choose whichever one you think is easier. I'm going to use 4x plus 2y equals 9. I'm going to substitute that in. I get 4x plus 2 times 5 equals 9. And now I'm just solving for x. 4x plus 10 equals 9. 4x equals negative 1 because I subtract 10 on both sides. Last step, I divide by 4, and I get x equals negative 1 over 4. Last step, I'm going to write this as a coordinate. So my answer is going to be negative 1 over 4, comma 5. Because I write x, comma y, and that is my answer. All right, so make sure you write down any questions, comments, or concerns you have on that example. But I'm going to flip the page and talk about solving problems with elimination that are slightly trickier than this example. So since these were already additive inverses, it was pretty easy. I just added straight down and then had to solve for y and then x, but not all of them are quite that simple. So I'm going to flip the page. Also, while I'm flipping this page, please send me a quick email if you are listening. So kleary@k12.somerville.ma.us. I want to know that you are actually listening to this. So if you're listening, send me a quick email. Now I'm going to define equivalent systems. So what equivalent systems are what you get when you multiply each side of an equation by the same non-zero number. The reason I bring these up is because we're going to use equivalent systems to set up problems to solve using elimination. So sometimes our terms won't be set up as additive inverses, but we can still use elimination by making equivalent systems and then solving those. It's important to note that equivalent systems have the same solution. So we're not changing our answer by making equivalent systems or multiplying them by the same non-zero number on both sides. We're not changing the value of this equation. All we're doing is changing the form so that we can create additive inverses to solve. So let me show you what that will actually look like in the context of a problem. I'm going to ask, what is the solution of this system? And we have 2x plus 7y equals 4 and 3x plus 5y equals -5. So we're going to solve this system using elimination. So again, I checked 2x, 3x, not additive inverses, 7y, 5y, not additive inverses. So I need to create additive inverses. So my first step is going to be to determine a common multiple for the coefficients of x or y. So if you guys don't remember what a multiple is, it's a number that you can get by multiplying these by another number. So I want to find a number that both 3 and 2 go into, or that both 7 and 5 go into. I'm going to use 3 and 2 since I know that they both go into 6, and that's a relatively low number. So I'm going to multiply so I'm going to take these two equations. I'm going to write them slightly off to the side over here. 2x plus 7y equals 4. 3x plus 5y equals -5. What I'm going to do now is multiply each equation to get coefficients that are additive inverses. And again, additive inverses are numbers or terms that when you add them, they become 0. So I'm going to put brackets around both of these because I know I'm going to multiply both equations by a number. So I noticed that both of these go into 6, so I want one of them to be 6 and the other to be -6. So what I'm going to do here is I'll multiply this top one by 3 because I know that will give me 6x. And I'll multiply this bottom one by -2 because I know that will give me -6x. That way I know these two numbers will be additive inverses and I'll be able to cancel them with elimination. So I'm going to make my additive inverses by multiplying by 3 to get +6 here and -2 to get -6 here. But again, just as a reminder, you have to multiply it to every term in there. So I end up with 6x plus 21y equals 12. So I can't just multiply this first number and change just that value. I have to change the value of every term in there. So I'm going to refocus this real quick. So I have to change the value of every term in there. And I'm going to do the same thing with this next one. I have to multiply every term in there. So I end up with -6x minus 10y equals +10. Now I'm going to solve so now I have a situation that looks just like our last example. I'm just going to solve that through. So I'm going to solve just like we solved our last one. So I'm going to add these straight down. 6x and -6x are additive inverses. Those cancel out. 21y minus 10y is going to be 11y. 12 plus 10 is 22. Divide both sides by 11 and I get y equals 2. Then I'm going to plug it back into either of my original equations. So I'm going to take 2x plus 7y equals 4. And I'm going to plug in that value of 2 for y. So I get 2x plus 7 times 2 equals 4. 2x plus 14 equals 4. 2x equals -10. X equals -5. So this is again just the same process that we did in our last example. I solved for y, plug it back in, solve for x, and now I'm going to write my coordinate. So my answer is going to be -5, 2, And that is my answer for that problem. All right, if you'd like to stick around, I'm gonna do one last quick check if you'd like more clarification. So I'm gonna flip the page and do one more example if you'd like to follow along. If you're feeling all set, you don't have to actually copy this, but for those of you that need another example, we're going to solve with elimination here. So I have 3x plus 7y equals 15 and 5x plus 2y equals -4. So I'm going to rewrite both of these because I know I'm going to have to multiply them by some number to get my additive inverses. If you want to pause this and try it on your own before I follow through with it, you're welcome to do that. So I'm going to try to cancel my y terms this time just to mix it up. So I know 2 and 7 both go into 14. So I'm going to need to multiply this first one by 2 to get 14, and I'll need to multiply this next one by -7 to get -14. So when I distribute that 2 into each term, I get 6x plus 14y equals 30. And I get -35, when I distribute that -7 in, -35x minus 14y equals +28. I'm going to add these straight down, and I end up with -29x. 14 and 14 are additive inverses, they cancel, equals 58. If I divide both sides by -29, I actually end up getting x equals -2. So 58 divided by -29 is actually -2. I'm going to plug that back into one of my original equations. So I'm using 3x plus 7y equals 15. This 2 is going to be, -2 is going to be substituted in for x. So I have 3 times -2 plus 7y equals 15, which becomes -6 plus 7y equals 15. Add 6 to both sides, 7y equals 21, y equals 3. So there are my two values. I'm going to write them as a coordinate point. And that is my answer. All right. Make sure you write down any questions, comments, or concerns you have on these so we can go over them together in class.